So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are going to be proving this rare identity actually. Like, literally, it's rare. I have never seen this. I just saw this yesterday only, and before that, I have never seen this in my life. And you know what? It's rare, but it's extremely easy to prove. Yeah, you just need one tool, and that tool itself I have proven in one of my videos, and I'll paste the link of the proof of the tool of in the description box of this video. Don't worry about that. So the tool actually it's not tool, it's everything for this. So it is pi times cotangent of pi z equals 1 over z plus this sum as n goes from 1 to infinity of 1 over z plus n plus 1 over z minus n. And I have proved this in my video, like in one of my video, and I'll just paste the link of I'll paste the link of the proof of this one, right? So you don't need to worry about that. So basically now you should ask me like, Aman, how would you reach from here to here? So let's just, well, that's why we are here actually. So let's just talk about that. Okay, so basically we are having this much thing. Now let's just talk about this one, the right hand side of this expression. So the right hand side is basically 1 over z plus, well, we can write this something, let's just expand this a little bit. So it's gonna be 1 over z plus 1 plus 1 over z minus 1 plus 1 over z plus 2 plus 1 over z minus 2 plus dot 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 all the way up to infinity. Now let me just write it in a different manner, right? We can write this as sum from negative infinity up to 1 over z minus 2 plus 1 over z minus 1 plus 1 over z plus 1 over z plus 1 plus 1 over z plus 2 and all the way up to positive infinity. And this is the same thing that is being written over here. So basically we can say that 1 over z plus the sum as n goes from 1 to infinity of 1 over z plus n plus 1 over z minus n is the sum is nothing but the sum as n goes from negative infinity to infinity of 1 over z plus n. Exactly, it is right. Okay, so basically we can write this pi times cotangent of pi z equals this all integers sum actually. So it's pi times cotangent of pi z equals the sum as n goes from negative infinity to infinity of 1 over z plus n. Well, let's just write it in a little bit different manner. Pi times cotangent of pi z times this, this sum as n goes from negative infinity to infinity of z plus n whole to the negative 2. Okay, so our next step is gonna be taking derivative with respect to derivative of this equation, of the equation with respect to z. Okay, so that's gonna give us, so basically taking the derivative with respect to z, pi times cotangent of pi z equals d over dz times this of this infinite sum actually. Okay, and it's z plus n to the negative, oh I'm sorry, it's not negative 2 but it's negative 1, and it's negative 1. Okay, so basically if we talk about the derivative, so yeah, since pi is a constant, so we don't need to care about that, and the derivative of cotangent is minus cosecant square, right? So basically minus cosecant squared of pi z, and with the chain rule we have the pi as well, because like we just took the derivative of this function and then we have to take the derivative of the argument of that function as well. Okay, and on the right hand side we would be having this sum as n goes from negative infinity to infinity of d over dz of z plus n to the negative 1. Okay, so that's gonna be negative pi squared actually. Wait a second, negative pi squared of cosecant squared of pi z and equals this sum as n goes from negative infinity to infinity, and the derivative of z plus n to the negative 1, it's gonna be negative 1 to the z plus n, negative 1, which is negative 2 actually. So basically negative pi squared cosecant squared of pi z is coming out to be the sum as n is going from negative infinity to infinity of actually negative in front, actually this factor, right? And it's gonna be z plus n whole to the negative 2. And finally we can say that we just got rid of these negative terms actually, and we can write this cosecant squared in terms of sine, which is the reciprocal of that. So basically it is coming out to be pi squared over sine squared of pi z equals the sum as n goes from negative infinity to infinity of 1 over z plus n whole squared. And hence proved, guys. Like, it was extremely easy, I would say. We just have to take the derivative, that's it. Like, literally you don't need anything else, we just have to take the derivative. And I think I haven't like proved the derivative of cotangent is minus cosecant squared. I think I should just check that out once, but it's easy to just take the derivative of that. Like, I have uploaded 3 videos taking the derivative of 6 functions, 6 fundamental functions. So from those methods that I have used in those 3 videos, we can easily prove this. The derivative of this one is this down. Actually, it's easy. So yeah, but again guys, if you want me to prove the derivative of the derivative of cotangent of pi z is minus cosecant squared of pi z times pi, so just tell me, I'll take another video to prove that down as well. It's easy. And for now, yeah, it's good guys, and it was extremely easy as you might see. Yeah, okay, so goodbye guys, take care, love you. And yeah, let me tell you something. I think last video was probably my shortest video I've ever made or I will ever made. So that's interesting, and that's extremely interesting, I would say. So you should consider watching that video as well, because it's just weighs around 1.16 minutes. So it's lovely. Okay, goodbye guys, love you, take care, and just stay tuned for the next videos, because I'm gonna bring a lot of things for you. And again guys, if you got to learn out of it, please make sure to like, subscribe and share. And if you have any doubts so far, you're free to ask me in the comment section. I'll be there to reply to your questions. Thank you so much guys, goodbye.